Okay, and this is problem number 3. We're trying to figure out what's difference in these two designs of these two wheelbarrows. So for these, since it gives us the distances from this wheel here, I think I'm going to have the wheel be my pivot point for both of these, my fulcrum. Okay, so we've got the force down from the load inside the wheelbarrow, 525 newtons, and we've got this force here from the wheelbarrow itself, 60 newtons, and we have this support force up here. Same thing over here, we have this weight down of 525 newtons. We have the weight of the wheelbarrow itself, 60 newtons, and we have this upward force, and we're trying to figure out what that upward force is. Okay, so we know that it must be true that the upward force F up must be equal to the 525 newtons and the 60 newtons combined. So, oops, I forgot one other force, 585 newtons. Excuse me. There's one more force that I left off. One more force. There's a force, a normal force, right here at the wheel, right? Forgot that one. So maybe I need to label these forces. There's so many of them. F up. There's the weight of the wheelbarrow. Weight. Sub B for barrel. There's the weight of the load. And there's the support force, N. So I need to change this equation a little bit. It's going to be N plus the force upward is equal to 585 newtons. But I don't know N, and I don't know the force upward. There's two unknowns. So I'm going to pick my pivot point down here at this end and write a torque equation. So by picking that point down here at the end, that eliminates that normal force up. And so I'm going to have the torque from the load plus the torque from the barrel is equal to the torque upward. So the torque from load is going to be 525 newtons times the distance away, which is, looks like it's 0.4 meters. It's kind of hard for me to see that. 0.4 meters plus the torque from the wheelbarrow, which is 60 newtons, times the distance away, which looks like it's about 0.7 meters, I think. And that's got to be equal to the force up times the distance away, which is 1.3 meters. And so I can figure this out. I get 194 newtons about for F up. F up is about 194 newtons. That's for the first case. Now let's look at the second case here, the other wheelbarrow. In this case, there's two forces, the normal and the weight of the load, that go through the pivot point. That means there's no torque from those two. So it's going to be the torque from the barrel is equal to the torque from the force up. Well, that's going to be 60 newtons times the distance of 0.7 meters equals the force up times 1.3 meters. The force up then ends up being 32 newtons about.